Hello, everyone, and welcome to our annual tour of the Joint Water Pollution Control Plant. My name is Genesis Rodriguez. I'm a public affairs specialist with the Los Angeles County Sanitation Districts. Today with me, we have Steve Krai, the manager of the Joint Water Pollution Control Plant, and then we have Wendy Wert, a civil engineer with us at the Public Information Office. And so today we're going to ask the grand old question, where does your sewage go? And we can't answer that question without taking a tour of the most vital plant to our entire sewer system, and that's the Joint Water Pollution Control Plant. So Steve, our plant manager, is going to take us a walk through it. And then after, we're going to go take a walk through a little hidden gem that's right next to the Joint Water Pollution Control Plant. We're going to take a walk through the Bixby Marshland with Wendy Wert. So if you could stick around for that. And if you have any questions throughout the entire tour, just feel free to raise your hand, or better yet, use the Q&A feature. That way we can keep all the questions better organized, and then we can get them answered in a timely manner. And so again, feel free to ask away. We have our experts here, Steve and Wendy. And without further ado, I'll let Steve take the stage. Steve.
Okay, thanks, Genesis. Let me share my screen here. Okay. Well, thanks for joining us this morning. My name's Steve Krai. I'm the plant manager. We'll be doing a virtual tour of the sanitation districts and the Joint Water Pollution Control Plant, followed by a tour of the Bixby Marshland. As Genesis said, we're going to talk about where your wastewater comes and what we do with it. And about 85% of our wastewater is from residential sources, such as your kitchen, sink, showers, toilets, and washing machines. And the other 15% is from commercial, industrial sources, such as refineries, paper mills, plating and dyeing companies, and breweries. There we go. Okay, here's our mission statement. Our treatment plants have evolved into resource recovery facilities away from being just wastewater treatment. And currently we reuse, as you can see on the left side here, we reuse a lot of water in the sanitation district. Since 1962, we've been recharging groundwater upstream. And currently here at the Joint Water Pollution Control Plant, we actually reuse about 25 million gallons per day on site. I mean, you see here in the middle, we also do power production at our landfills, and also here at the treatment plant, we collect the gas and produce power. And then on the solid waste side, we also do a lot of recycling of the solid waste. So the sanitation districts were formed in the 1920s to build the sewers in this plant to collect and treat wastewater in the LA region to protect the public health by keeping raw sewage off the streets, and also sending clean water to the ocean. This map here shows the locations of our wastewater treatment facilities and details of the sanitation district's governance here. We serve about 5.5 million people in LA County, and then the city of LA serves the other 5 million people in the county. And you can see that the range of our service area here. We've got the high desert with plants up in Palmdale, Lancaster. Out in the Santa Clarita Valley, we've got Saugus and Valencia plants. You can see the NR here, that's our newest sanitation districts, Newhall Ranch. And then down here, and what I'm going to talk about mostly, is the joint outfall system and the plants here. So the sanitation districts own and maintain the large diameter trunk sewers, while individual city public works departments take care of the small local sewers. This photo here illustrates the size of these sewers, and you can see how large these are and how deep. And we have about 1,400 miles that we own and operate, maintain, clean, and inspect throughout the year. So this schematic here, we're going to look at the county, and first we're going to look at the City of LA system. Their Hyperion plant is equivalent size to our Joint Water Pollution Control Plant. And you can see here the outfall that goes out into the Santa Monica Bay. They also have 3 other water reclamation plants in their system. But I'm going to talk about our system, and you can see, again, the plants up in the high desert, Palmdale, Lancaster, they serve about 175,000 residents each, and their plants are treating about 12 million gallons per day. Over in the Santa Clarita Valley, you have Valencia and Saugus, another 250,000 people are serviced here, and the total flow for these plants is about 20 million gallons per day. But mainly I'm going to talk about the joint outfall system here. It's a gravity system for the most part. As I said, we manage the large trunk sewers here, 1,400 miles. We've got about 50 pump stations. That's these purple dots you can see here. So it's a gravity system for flow, but anytime we get to a low point and have to pump it over a hill, that's where we have a pump station. The other thing that's unique about this system is all the solids from these upstream plants get put back into the sewer downstream of the plant. So down here at the Joint Water Pollution Control Plant is where we're actually managing the solids for the whole system. So these upstream plants, we pretty much cherry pick the residential cleaner wastewater without any refineries or industrial dischargers. And then we're able to reclaim that water through the process. We use a primary treatment for a physical settling process, secondary treatment for a biological removal process, and then finally sand filters up there. And then the water can be reused for golf courses and parks and groundwater recharge and things like that. The total flow for this joint outfall system is about 400 MGD, 400 million gallons a day. We're treating about 260 million gallons per day down here at the joint plant, and another 130, 140 million gallons per day at these upstream plants. And a good percentage, the majority of that is being reused currently. And as I said, the joint plant here, we handle the solids for the entire system. We also have an extensive industrial waste pretreatment program where we take out, make sure that industries take out heavy metals, any other toxic compounds, volatile organic compounds that might cause problems in our treatment process. And those are required on the industries to do the pretreatment before they discharge to our sewers. So as I said earlier, the plant's been around since 1928, as you can see here. Capacity is 400 million gallons per day, and our flow is about 260. The operational area is about the blue area here. It's about 220 acres. And then we have another 160 acres of buffer property. So as far as the plant itself, this is our administration office where you come in and see us here. You can see the roads and how to get here. We've got 4 main areas of the plant. The primary treatment is on the west side of Figueroa Street, and then also the digesters. Those are the large circular tanks here. And then secondary treatment is on this side of the street. And then solids processing is north of the railroad tracks. And then as Genesis mentioned earlier, we also have a little gem here, the Bixby Marshland, and Wendy will be talking about that after I finish talking about the plant. So I'm going to talk about each of these areas in more detail, and we're going to follow the water treatment first through the plant. This is the blue, and then the solids here is the red. So as I mentioned, the main 2 parts of the process are primary treatment, secondary treatment. These primary settling tanks, we're just duplicating nature, creating a large spot or a wide spot in the river, I guess you could call it, where we slow the water down from 3 feet per minute to 3 feet per second to 3 feet per minute, and settle out about 75% of the solids. From there, it goes to a secondary treatment process, and this is a biological process where we take out what we call dissolved organic material. And the way you could think of that is like if you have a cup of water, clear cup of water, and you dissolve some sugar in it, and that's organic material and food. But once you pour that sugar in and then dissolve it, when you look at that water, it's still clear and you can't see that food in there. And it's the same way with the wastewater. We've got a lot of dissolved organic material you can't see in there, but the bacteria love it, it's food. And so that's what this biological process does. And it's called activated sludge. So we use these covered reactors and then to clarifiers, and the bacteria, the microorganisms settle out, and then we return them around to the front of the reactors and keep recycling that activated sludge. From there, we go to disinfection, and then it can either pump or gravity flow out to the ocean. So the first step is our preliminary treatment, where we have 3 main sewers coming into the plant here, 1 for each of these 3 bar screens. You see 3 here with 1 sewer, 3 in the middle with another sewer, and then 3 to the right side here with another sewer. And these screens have about 1 inch space between the bars. And this takes out any large material, anything that gets into the sewer that we don't want going downstream that could damage downstream equipment. And anything, basically, if you picture anything that could fit through a manhole lid, we've pretty much seen it here. We've seen, you know, rags, woods, large debris like mattresses. There was even one year where we had a sewer collapse that was right under a nursery, and they had a sinkhole, and right in the middle of a rainstorm, a bunch of those 5-gallon and 15-gallon pails of plants fell into the sewer and then flowed down, and we're getting caught up on our rakes, and the operators were pulling those out. So this is what these rakes look like. Here's a clean one after we did some maintenance on it, and then this is what it looks like when it's been in service. So if you notice here, probably the biggest thing we take out is the rags, the disposable wipes. So you can see the disposable wipes don't break up like toilet paper, so please don't flush the wipes, even if the box says flushable. So over here, you can see the screens on the left side. The water flows through, and as I said, it's a gravity system, so gravity flows to here. And then underneath these gearboxes, we have vertical turbine pumps that lift the water into these channels here. And from these channels, it then gravity flows through primary treatment. Before it gets into those primary sedimentation tanks, we have grit chambers here. And the purpose of the grit chambers is to remove grit, sand, rocks, and other heavier inorganic material. We add air here to try and keep the lighter organic material in suspension. So we weren't able to do a drive-through tour like we've done the past few years, but we'll do the next best thing here. We've got a video for you. And so we head in here, you can see the cooling towers from the power plant on the left, see the digestion tank here, but this is the inlet works that we just looked at with the bar screens. Got the bar screens there, and then the inlet pumps, and the grit chambers in these covered tanks over here, our sedimentation, which is the main bulk of our primary treatment process. As I said, it slows the water down to about 3 feet per minute, settles out about 2/3 to 3/4 of the suspended solids, and it takes about an hour and a half for the water to flow from one end of the tank to the other. And then from there, we then pump this water across the street to secondary treatment. So if we were able to get out and look at a tank, this is what you would see here. And these tanks are about 10 feet deep, about 300 feet long. The solids that settle out in the bottom, we collect in a hopper and then pump to our digesters for further treatment. The material you see on the top here, this is fats, oils, greases, other floatable material we call skimmings. This flight moves along and skims that off. And then we also pump that to the digester to be further treated. Okay, so I'm gonna take a quick break here. Genesis, do you have any questions in there that we might need to answer, or should we just continue?
No, I think we're good. You can keep going.
Okay, sounds good. Okay, so as I said, from primary treatment, we pump it across the street to secondary treatment here. As I said earlier, we're rated for 400 million gallons per day. We have 8 reactors, each rated for 50 million gallons per day. So there would be a reactor here, and so on. They're kind of set up in pairs here. And each reactor has 26 clarifiers associated with it. So the primary effluent mixes with those microorganisms I was talking about, and it spends about 2 hours here in the reactor flowing through and then into the clarifiers. And it takes about 3.5 to 4 hours for those microorganisms to settle in the clarifier. And then we have a pump station, and the pump station pumps those settled microorganisms back to the front of the reactor. So these are aerobic bacteria, and they like oxygen. And we take ambient air, which is 21% oxygen. We cool it and liquefy it. And then we use a distillation process. We have a 150 ton per day plant here, 150 ton per day plant here, and a 325 ton per day plant here. And what we do is we liquefy the air, and then we separate oxygen and nitrogen based on the boiling points. Nitrogen boils about negative 321 degrees Fahrenheit, and oxygen at negative 297 degrees Fahrenheit. So these are about negative 300 degrees on the insides of these columns. And this shows you, when I talk about the microorganisms, you can kind of see the various kinds here. And these are the ones that are feeding on that dissolved organic material, or as I described earlier, that sugar. I got another video for you here. We're going to fly across the secondary reactor. So the oxygen is piped into the headspace. Underneath these gearboxes, we have surface aerators that do the oxygen transfer. They're just big propeller blades stirring up the surface and transferring the oxygen. And then from there, the mixed liquor, we call it, the bacteria, and the water flow into these tanks. And then the bacteria settle out and get recirculated back to the front of the plant. And then the effluent moves on for further treatment. And just in case you were wondering what the water looks like, this is the water coming into the plant. We call it the influent. As I said, about 3/4 of the solids and about half the dissolved organic material is removed in primary treatment. And then the remaining portion, or virtually all of it, is removed in secondary treatment. Okay. So here you can see the clean water that we're sending out to the ocean. We disinfect this before it heads out to the ocean. We use 12.5% sodium hypochlorite of bleach, as compared, it's more concentrated than your household bleach, which is about 5% concentration. So it's about another 4 hours out to the ocean here, and the disinfection takes place there, and we have virtually no chlorine residual by the time we get to the ocean. See, we have an 8-foot and a 12-foot tunnel that were installed back in the 30s and 50s. Those have been in continuous service for many years. And then you can see the outfall here. We have 2 outfalls that go right out to the edge of the continental shelf, a 90-inch and a 120-inch that are normally in service. And then we have 2 older outfalls that are a little closer to shore, and these are just for hydraulic relief during rainstorms and things like that. You can see the diffuser ports on the end here, and our target is 166:1 dilution out there. These are, as you can see, 1.5 miles offshore, nearly 2 miles offshore, and about 200 feet deep out there. We also have a very extensive marine biology ocean monitoring program here. You can see our marine biologists out on the boat here. They take all sorts of samples of the water at various depths of the water column. They catch fish, look at the fish and other sea animals out there, and then also take samples of the sediments to look at the benthic organisms to make sure that we're not having any negative impact on the environment with our discharge. So as I said, the existing tunnels have been in service for many years. So we have this thing called the Clearwater Project, where we looked at the reliability of the system moving on into the future. And the one thing that came out of this project that was identified was that we had a single point of failure with these tunnels and needed to have some reliability moving into the future. So ultimately the decision was made to build a new tunnel here. You can see the serpentine path. We tried to keep it under the public right-of-ways, under the streets, and also tried to make it routed so it went perpendicular across any earthquake faults. And it also uses, the design uses innovative technology they've perfected out in Japan, where you use flexible joints around the earthquake faults to help for stability in case of an earthquake. And then the plan would be that once this new tunnel is in service, the 2 existing wood tunnels would be taken out of service, repaired and refurbished, and then we'd have plenty of sufficient redundancy there. And you can see the construction started this past year. This is the access shaft for the tunnel boring machine that will be installed. And then this is also where the soils will be excavated out of and then hauled offsite. You can see over here, they're working on the connection over to the existing piping in the plant. Oops. And here you can see a tunnel boring machine. These are very sophisticated machines. It's a couple stories tall. It's currently being built over in Germany and tested, and then it'll be disassembled and then shipped over to the US and trucked to the site, and then lowered down through that access shaft and then put together down in the ground, and then we'll tunnel the 6 to 7 miles out to the ocean. Okay, Genesis, we're at another break point here. Do you have any
Yeah, I
questions?
have actually a few questions that came up. Um, so one, well, how many people are working at the Carson site and at the sanitation districts as a whole?
Um, for the treatment plant itself, we have about 300 people that work on site here, and that's spread around maintenance and construction, mechanics, electrical and instrumentation, laboratory operators, engineering and administrative staff.
Great. And the next question is, how does heavy rain affect the plant capacity?
Good question. We do see quite a bit, a significant increase in flow during rain events, and that's due to a couple of reasons. You've got inflow and infiltration through the soil, and the soil gets saturated, and if there's any leaking joints in those 1,400 miles of pipes. But what happens a lot of times too is there's street flooding, the storm drain system gets overwhelmed, and then when the street public works departments are out trying to drain the streets, they start popping manhole lids on the storm drains, but a lot of times they lift our manhole lids and water stormwater flows into our system too. So during a rain event, we'll actually see that 260 MGD average flow, could even double or get up around 550, 600 MGD at peak rainfall infiltration events, and have an average daily flow of over 400 MGD, which is right around our plant capacity.
All right, great. Our next question is, will the old tunnels be kept as a backup?
Yes, we're gonna take them out of service when the new tunnel's in service, and we'll inspect them and make repairs as necessary, and then put them back in service as a backup.
Great. And so someone said, seeing a TBM coming in via trucks and assembled underground will be a really cool thing to see. What are you doing with technology? Are you going to automate portions of it, add in IoT sensors for more real-time data?
So it sounds like the question's on specifically the tunnel boring machine. Yeah, I don't know the specific details on that. I know this machine, when it gets, they're going to excavate using normal methods, I guess, this thing's more than 100 yards long, so they're going to excavate, and then they'll build that machine down in that starter tunnel, they call it. And then from there, it'll start working out towards the ocean. But my understanding is that there are going to be numerous soil sensors along the way to check for settlement and other things that may be of a concern. And this is an electrically driven machine.
Yeah. So just a few more questions and then I'll let you get back on, Steve.
Okay.
Can you please discuss the carbon dioxide stripping in secondary?
Sure. What the question refers to is we've got, when we put that oxygen in underneath the headspace in that covered reactor, those bacteria, when they break down the microorganisms, one of the byproducts is carbon dioxide. Just like us, we're aerobic organisms. When we breathe, we breathe out carbon dioxide. It's the same way with the microorganisms. They give off carbon dioxide that causes the water to become slightly acidic. pH drops from 7, which is neutral, down to about 6.3, 6.4. And then, so what we've done is that, and the reason we have this stripper to strip off that CO2 is because with the low pH, if we reuse that water, it's very corrosive. So in the 4th stage of our biological reactors there, we pipe air in, which is 21% oxygen. And then and it has virtually no CO2 in it. So the CO2 that's in solution, that's concentrated, it wants to become in equilibrium with the water or the air that's blowing across at 21% oxygen. And so it basically causes the air, CO2 to come out of solution into the ambient air that we're blowing through the 4th stage there. So it's called the stripper. So that's where the name comes from, CO2 stripper for the 4th stage.
So
Okay. It's okay if I continue on, or you
Yeah,
had another one come in?
just one more about
Okay.
the tunneling. Well, it's a few actually in one. When will the tunneling start? Will residents be able to hear it, and how long will it last?
Okay. Back up here. So here, I forgot to mention, this shows where the work will be at each site. So that access shaft is right at the yellow dot here, and there'll be work there the entire 7 or 8 years that this project is ongoing. The tunneling, as you can see here, they think it'll take about 4 years. That, as I said, the tunnel boring machine will be installed. Excuse me, it'll be delivered and installed in early 2021 or 2021, and then they'll tunnel out to the White Point area here, and then there's some connections they have to make and modify our manifold structure here. That'll take, as you can see, 3 years or so to do that work out here. So to answer their question, we'll move forward here. You can, actually it's not in this picture here, but along Figueroa Street here, there's on the right side of your screen, which you can't see. If you drive by there, you'll see a large noise wall that's a barrier for the work that'll be taking place here. The work did start already last year, so hopefully the impacts on the local community will be minimized. There's also a number out there too. I don't have the number on my presentation here, but whoever put in that question, we can also get you the number to call if you have any concerns or any issues. And we can also put you in touch with the field engineer on the job to give you more detailed answers.
Okay, great. We'll let you move along.
Okay. Let's see here. Okay, so as I had mentioned earlier, our upstream water reclamation plants have been recycling water for many years, as far back as 1962, for groundwater recharge, and then currently reuse about 100 million gallons per day for groundwater recharge barriers, and then also reuse on golf courses and green belts, parks, and things like that. The reason we haven't done any recycling off-site with our water up to this point is we have ammonia in our water. We don't do nitrogen removal. The upstream plants do take out the ammonia. And then we also, because of the industries that discharge to us, the water has very high salt content. So it's always been cost prohibitive to clean the water up further. But the technology has improved significantly. And now, as you can see up here, we've got a joint project with the Metropolitan Water District called the Regional Recycled Water Project. And if you go to this website here, there's additional information on the project, but the gist of it is we've got a demonstration facility that we built where we're treating 500,000 gallons per day of water and cleaning our secondary effluent up to drinking water quality, so you could actually drink the water by removing the ammonia and the salt. This shows here where the demonstration facility was built, and then we've got room here on one of our buffer properties where we could build a full-scale plant if necessary. So this is what the demonstration facility looks like. It was just recently built, started up this past month. These tanks here is where the ammonia removal takes place. And then these two vessels are called MBRs, or membrane bioreactors, that are being evaluated and tested. And then from there, after the ammonia removal, underneath the tent, we have reverse osmosis membranes that take out any salt and any other remaining contaminants that might be in the water. And then there's also UV disinfection and advanced oxidation with hydrogen peroxide. So there's a finite amount of water on the planet, especially in Southern California. So it makes sense to recycle and reuse as much as we can. And we can probably reuse up to 150 million gallons per day from our plant. And where would this water go? As I mentioned, there's various sources or locations where we can do it. There's the saltwater barrier injection wells in the South Bay, and then also in the Long Beach area. And then spreading basins, Orange County, Rio Hondo, and up at Santa Fe, where it can, the water can be spread and then percolate down into the groundwater and be used for drinking water. And then the water that is being produced there or would be being produced from our facility would be clean enough that it could actually go to the Demon plant or the Weymouth plant, which are the MWD's drinking water plants. So it could go directly to those plants on the front end to be treated and then used as drinking water. Okay, so Genesis, this is another break if there's any questions that came in.
How often do you check to see if under ocean pipes are leaking?
That's a great question. We actually check throughout the year. There's once a year that we actually have a submersible vehicle. It's called an ROV, remote operated vehicle, that the marine biologists use, where they can go down with this little sub, and it's got a camera, and they'll go all along the route of the outfalls and check for any leaks or abnormalities, or if anything was damaged during the storm event when a lot of waves come in. And then they also, all our marine biologists are trained divers, so they also will dive down to some of the more shallow sections of the outfall to do inspections also, and also when they inspect the sea life there and looking for any abnormalities or anything out of the ordinary.
So our next question is, why does the clean water flow into the ocean? Why not into the rivers?
Well, for the water reclamation plants upstream, they actually do flow into the rivers and then eventually make it out to the ocean. Where we're at, our Wilmington drain, actually, that's the storm channel right next to us, that actually flows into Machado Lake. Because of as I said, the ammonia and the salt concentration in our effluent, that wouldn't be good for the lake. So we go out to the ocean, and the ammonia and the salt, there's a lot of ammonia and salt in the ocean already. So what we're adding is kind of a drop in the bucket. So there's no negative impact from us going to the ocean.
Okay, so now the majority of questions, everyone wants to know about the solids. What happens to the solids? And so, Steve, I'll let you continue on to that next chapter.
That's like a segue here.
Yeah, it's perfect. I saved it for last.
Okay. So as I said, the first part we went through, and we looked at the blue portion here through the water of the plant. Now we're going to go look at the solids treatment, and we've got solids that settle out in the primary treatment and get pumped to digesters, and then those microorganisms, just like us, when we eat, we put on weight. Same thing with these microorganisms. They're feeding on all that dissolved organic material. So we recycle a constant quantity, but any growth we waste out, and we call it waste activated sludge. And we send that to the digesters. These are anaerobic digesters. The same bacteria that's in your stomach and your gut. We use these digesters. They give off gas, and the gas we collect, run through a power plant. The digested sludge then goes to centrifuges for dewatering, and then is hauled off site for recycling. And I will go through each of these steps here on the following slides. Okay, so as I mentioned, anaerobic digestion is the centerpiece of this solids treatment. These are huge tanks, 3.5 million gallon tanks. There's about 10 feet above ground, and then another 30 or 40 feet below ground. And we've got 24 of these, so think of that as 24 tummies that we have on site treating these solids. So, and about 50% of the solids are broken down by the bacteria in these digesters. We're able to look at a cross section. This is what you would see. The gas that comes off in the headspace is pulled off with these compressors, and then these lances blow the gas back down to about here in these draft tubes. There's no moving parts in there. It's all static mixing. So the gas bubbles come up and create a current and create the mixing in there. The advantage of digestion is it kills pathogens. It makes the solids that are left easier to dewater, and obviously produces a gas that we can beneficially reuse. If we were able to take you inside one, this is what it would look like. Just to give you a feel for the size, if you see this board over here, this is about an 8-foot long board, so 6-foot person would be about that tall there. As I said, these are 50 feet deep and 125-foot diameter, 3.5 million gallons. And we have so many because we need at least 15-day minimum detention time to properly treat the solids. The digester gas we use to produce power. We're energy self-sufficient at this plant here. We use gas turbine technology. It's like a jet engine. We use digester gas as the fuel. Goes through a combustor section, through a turbine, and then that turbine spins a gearbox, which is connected to a generator and produces the power. This is what it would look like if we could take you in to see it. We've got 3 gas turbines producing about 9.5 megawatts each. And we save $15 million a year by taking that gas and recycling it and producing our own power. Another innovative thing we do here at the plant is the hot exhaust. Rather than just coming out this stack here, we have these heat exchangers, and we run the hot exhaust through that. And the heat exchangers are filled with water, and that boils off the water to produce steam. And that steam is then collected and run through a steam turbine to produce another 4 or 5 megawatts of power. And that's why it's our plant is commonly called the combined cycle power plant, because there's a gas cycle and the steam cycle. We also, as I mentioned, the digesters are the same bacteria as in our stomach, and the wastewater comes in at 75, 80 degrees, and these digesters, we need to heat them up to 96 degrees. So we use boilers, produce low pressure steam. We use the digester gas as fuel and produce the steam, and then that's the steam that's piped to the digesters to heat the digesters. Another thing we're doing at this plant that we just started up probably 3 or 4 years ago is we're getting more energy by taking in food waste into our anaerobic digesters. There's new state laws that say that you have to remove food waste from landfills, and the reason for that is it's a resource. There's a lot of energy value in that. So we had a demonstration project with Waste Management where they took food waste, pre-processed it off-site, sent it to our digesters, produce the digester gas. As I said, we can produce or use, make steam with the gas and electricity. Biomethane is if you take the gas and actually clean it up to natural gas pipeline quality and re-inject in the pipeline. We're not doing that here, but some other plants in the country are. The digester gas has about 65% methane, and you have to concentrate it to put it in the pipeline. We actually have a vehicle fueling facility on site for CNG, and that doesn't have to be cleaned quite as clean as pipeline quality. So we do have a project to with a cleanup skid to take our digester gas and use it for vehicle fuel. About 80% of the solids from the food waste are converted into gas. The other 20% are then hauled off site for composting and recycled as fertilizer on farms. This shows you here what the food waste looks like. Oh, I forgot to mention, a lot of the residential food waste we already get, it comes in through our garbage disposals and through the sewers to us. So when we're talking about a food waste program, we're mainly talking about commercial food processors, grocery stores that have a lot of spoiled food, restaurants, grease traps from restaurants, things like that. So you bring that in, it's got a lot of contaminants in it. You can see from utensils, metal that have to be screened out. They use screens to take out the plastics, broken glass, and any other debris. And then you're left with this nice food waste smoothie that we then haul in tanker trucks, offload into these tanks, and then we can pump it across the street to the digester. We also take some food waste at the front of the plant that then flows through the treatment process and gets pumped to the digesters through the primary treatment sludge. Okay, I guess that's another break, Genesis. Any more questions before we move more into solids here?
Could you raise your voice just a little bit?
Oh, sure.
I think some people are having trouble hearing you.
Okay.
And then, so the next one we're going to get to is, how often do you do maintenance or overhaul on this?
Well, as far as the plant itself, as I said, we've got quite a few people that work here. We've got, technicians, maintenance, construction, and mechanics, and we've got a very extensive preventive maintenance program where that's what they do basically day in and day out, is do preventive maintenance on the various pieces of equipment and electrical switchgear to make sure that everything keeps running, because obviously we run 24 hours a day, 7 days a week, so we can never shut down. And part of what we do is try and design in enough redundancy so we can take pieces of equipment out of service to do maintenance, and then without impacting the treatment process at all.
Cool. So our next question, and then we'll move on, is what do you do with all the plastics that come in with the food waste?
Well, as I mentioned there, the pre-processing, we try to take out as much plastic as possible, but obviously some does get by their screens. And in those digesters, we actually do have to take the digesters out of service about every 8 or 9 years for cleaning. So as I mentioned, we have 24 digesters, so there's always one out of service being cleaned at any given time. And that's just to clean out any grit, sand, rocks that might settle in the bottom, and then also any plastic or floatable material that might have built up in a mat on top of the digester. So we clean all that out about every 8 or 9 years, like I said. Any more questions?
Great, we'll let you keep going for now.
Okay, thanks. Oops. Okay, so for the digestive solids, when they come out of the digester, it's about 2% concentration, and we thicken it up to 28, 29% in these centrifuges. It's uses centrifugal force. It's very similar to the spin cycle of your washing machine. We produce in these machines, they're spinning at 2,500 RPM, so we produce about 2,500 Gs of force and separate the water from the solids. This shows how it works. We had a little bit of polymer here to just improve the flocculation, get better recovery of the solid material. As I said, it's about 29% cake coming out, and then virtually no solids in the centrate going out the back end of the machine. And here you can see the solids. We use conveyor belts to move the material around. It's called cake because, as you can see, it looks like moist chocolate cake. And surprisingly, even though this looks pretty dry, it's about 70% water still. So there's a lot of moisture left in that. Okay, and these inclined sections here, this is where the conveyor belt went up. That video we took was right on top of the silos there. Those are storage silos where we can store the biosolids if we have problems hauling things offsite. If there's a, due to weather or earthquake or something, that a freeway is closed and we can't get to a reuse site, we do have some storage capacity on site. But from the silos, there's a conveyor belt that takes up to the truck loading station, and then we load the trucks. And we're producing about 1,200 wet tons per day of material, so about 50 trucks a day hauling material out of this site. This shows where we take things to. The plant's down here in Carson. It's a mix of properties we own as well as facilities that are privately owned. The South Kern and Nursery Products are compost facilities owned by Synagro. This landfill is owned by Holloway. Liberty Compost is a private entity. Denali, we haul some of the biosolids out to Arizona for land application out there. And then Tulare Lake Compost and Inland Empire are owned by the districts. Inland Empire Composting Facility is a joint venture between Inland Empire Utilities Agency and the districts, and that's owned and operated by us. And then Tulare Lake Compost is fully owned by the district. Here you can see the diversification. We try to spread things out, so if we have a problem at any one location for whatever reason, we don't have all our eggs in one basket. We don't have to, because obviously we're 50 trucks a day have to go somewhere. This shows the district's own facilities. Westlake Farms is where Tulare Lake Compost is located. That's up in Kings County, just outside of Kettleman City. It's about 180 miles north of here. Inland Empire is over by the Fontana Speedway. And then Mesquite Regional Landfill is a facility that was created by our solid waste department. And ultimately, when all the landfills in Los Angeles County close, we'll be rail hauling our solid waste out there. You can see here on the right side, this purple box is where the compost facility is, and they compost our biosolids with the wood waste from the Central Valley, and the finished compost is then land applied on this farm, Westlake Farms, and that's the black bounded area there. For the biosolids composting, here's another example of what a compost site looks like. This is one of the Synagro sites. Again, they're using wood waste from the farms and composting it with the biosolids. The advantage of using that wood waste is instead of burning and creating smoke and the air quality hazard, you're able to use the compost to break it down and then reuse that material on the farms as fertilizer. This is the Inland Empire facility. It's an indoor facility to contain the odors from the process. It's also compost with wood waste and green waste and mixed with the biosolids. This one shows direct land application out in Arizona. You can see the biosolids here on the farm. There's a lot of moisture content. It's dry, fallow ground out there, so the moisture is helpful for the farmers as well as the nutrients. As I said, there's the nitrogen with the ammonia and also iron in there that the plants like. They grow food crops, but not for human consumption. So they'll grow alfalfa on these fields, but this, as you can see, they've done cotton on this field at this time. Okay, so that was solids processing. Any questions, Genesis, that have come in?
Yeah, so one, you've got an awesome voice, but could you please
I'm sorry.
raise it up a little bit?
Okay.
Some people can't hear you.
Well, chime in if I'm fading off. Sorry about that.
Okay. No, I just got that question right now.
Okay.
So most of our questions right now, that everyone's very interested because this is all sounding very smelly. So they want to know, how do you do it so that it doesn't smell? How do you keep the solid waste from smelling? That's our main question.
Okay, well, let me go through the odor control here, and then we can see if they have any further questions or if the questions were answered. How's that sound? Okay. Let's see, I'll try and speak up a little here too. Sorry about that. So the plant's been here since 1928. So, there was nobody around, but the community's grown up around us over the last few years. So we want to be a good neighbor and made the decision a number of years ago that we need to improve odor control and try not to have any, our goal is not to have any odors leave past the fence line. And so we spent over $70 million on upgrades in the plant over the past 15 years. One thing I want to mention that we do get a number of calls with odor complaints, but the majority of them are not from the plant itself. It's actually the sewers that come into our plant are quite odorous, the headspace, and we go out and we try and seal up all the manhole lids as much as possible with silicone around the edges, and then also corks through the pick holes. And the reason is because a lot of these sewers go many miles. There's sewers that come to this plant that come from as far away as Pomona. So the solids are in the sewer for a long time flowing down here. So the sewers go anaerobic, and some digestion actually takes place in the sewers and give off that H2S gas, that rotten egg smell. And if those manhole lids aren't sealed up well enough, then odors can come out there. So that's one thing we do in the sewers to try and keep the odors from coming out in the streets. The other thing we've done over the years too is added on some of these, they've added carbon canisters on the inside of the manhole lid, and that also activated carbon that neutralizes or absorbs the odor before the air can get exhausted out, the foul air out into the street. So with that said, so one of the big projects was to add these covers, these flat covers. They're gasketed. Many years ago, these tanks weren't even covered at all. So now they're covered with these gasketed covers to seal them up. And then we have blowers that pull vacuum on the headspace under the covers. And as you can see here, there's a connection for each tank. It pulls the foul air up and then the foul air gets pulled over to our odor control station. And then there, it's a two-stage process. The first stage of the process is this biotrickling scrubber. These are blowers here, and the foul air gets pulled through this biotrickling scrubber. And this is filled with lava rock, and we keep it moist. There's water continually being recirculated across it, and a biofilm grows. And so it's a biological process. The bacteria actually feed on the sulfur and oxidize the sulfide in the H2S to sulfate, basically creating sulfuric acid, which is not odorous like the hydrogen sulfide. And then the second stage of the process is volatile organic compound removal. Because we do have some refineries that have trace amounts of volatile organic compounds that are in their pre-treated wastewater, those come out and are in the foul air too. So we use activated carbon in these scrubbers to take out those volatile compounds of benzene, toluene, and vinyl chloride, things like that, any trace amounts. Over at solids processing, it's a different type of odor over there. You can see the blowers over there. You have ducting here with pulling foul air off the silos. You have sort of pulling foul air off of the conveyor belts over here. And it's more of an ammonia-based odor and complex sulfur compounds like dimethyl disulfide, mercaptans, things like that. So we use compost or a wood waste product, and we keep it moist so biofilm grows there and it neutralizes those type of odors. One of the other really odorous parts of the process is when we're loading these trucks. And as we load the trucks and the biosolids, you can see here getting stirred up, that's when the odors come out. So on the truck loading station, we have these air knives, which creates an air curtain to try and keep the odors in during the loading process. But when these trucks do pull out and wait at the light right before they get on the freeway, there is potential for odors there too. You could probably smell it. And then the last slide I've got here is related to the cost, how much it costs to operate this plant and the collection system, the sewers, all the upstream water reclamation plants. And so you can see here, it's less than $30 a month, which is compared to the other cities, large cities of comparable size. It's one of the most cost-effective agencies in the country. Okay, so any other questions? Did I answer the odor control questions, Genesis?
Yes, you did. Thank you. Hope you're ready for this because we've got a few questions for you.
Okay.
So first, do you have industrial health and safety employees on site?
Yes, we have, the district has a environmental health and safety group that oversees all our safety programs. And then we have a analyst that's assigned to our site that we work with.
Great. So next, in many countries, people regularly put toilet tissue in the trash, not the toilets. Would that make a difference if we did that here?
The toilet paper isn't a problem. It breaks down, it decomposes and dissolves in the water pretty quickly, and it doesn't affect our treatment process at all. It's the disposable wipes that are made of a different fabric type material, and those don't break down, and that's what causes the problems. And yeah, those wipes should be put in the trash, not in the sewer.
So where are the distributors that eat the solid waste located?
Distributors that eat, did you say eat the solid waste?
Yeah.
What do you mean by eat?
I don't know. That's what the question had.
So, well, we could refer them to, we do have the tours for the Puente Hills MRF, the solid waste side of our business. There's information on our website. See the website here, lacsd.org.
Yeah, LACSD.
You can get lots of information there on the solid waste side of the business. And, there's a couple active landfills still in the LA basin, as well as our material recovery facilities where we recycle a lot of materials.
Great. So next, what do your typical environmental emissions look like every year?
On the water side, we've got what's called an NPDES permit with the EPA, and there's over 20,000 different parameters we monitor all year to make sure we comply with all our limits, to minimize our impact on the environment. And then on the air quality side, we have limits on our nitrogen oxide, our NOx emissions from the power plant, and any, we also have engines for pumping water. And so we have limits on that for carbon monoxide, carbon dioxide, and NOx. So we comply with all that stuff too.
Okay, so there was another question. It says, what do you do if there's a power outage at the joint plant?
It's a good question, because we're in a unique situation. As I said, we have our power plant on site, so we're energy self-sufficient. So we actually, that's our main source of power, and we have Edison as our backup power. So if Edison fails, it's really no impact on us, because we're generally always exporting power. But in the event that we had a problem at our power plant and we were using Edison power and Edison also failed, we have standby generators in the plant also to keep the process running, keep the water flowing through the plant so we don't flood the plant.
Okay, great. And I'd just like to remind everyone, we have a few questions to answer, but we're going to do the walkthrough of the Bixby right after some of these questions. So next, Steve, so did you have the number on how much energy you generate every year?
Well, it's a continuous export is about, or production is about 20 megawatts, and we use 18 megawatts, and we're exporting 2 megawatts usually.
Cool. And so then next we have, are you hiring? And how do you hire for plant operations?
Yeah, we're always hiring, more or less. If you go to this website, there's an employment opportunities link there that takes you to, I believe it's NeoGov website where you can do electronic applications. We're always hiring for various positions. Because of this impacts of COVID, we kind of have a soft hiring freeze right now, where we're just, we're still filling frontline positions, but we kind of have a slowdown for a short period of time here until we kind of see financially what the impact is from, you know, this pandemic. So you should be able to look at that website and see what our current openings are.
Great, yeah. So on the main homepage, there's a button right under the slideshow, and it says jobs. So if you click on that, it'll lead you to the links to find for external positions. So the next question is, how has the effluent changed since the pandemic? Is there less waste? That's a great question.
Yeah, that's good. And actually I've gotten numerous calls about that. And but what we saw initially was a little bit of a drop off during the lockdown, you know, when everybody had to stay home for 5 or 6 weeks. We did see a drop of maybe 5 or 10% in the flow because some of the industries that discharge to us were shut down. But we really haven't seen overall, you know, since things have opened up a little bit more here, the flows are back to about normal where they were. And the reason is, whether you're at work or you're at home, you still have to use the restroom. So as I said, that's like 85% of our flow is the residential wastewater.
So another question, I think it's more for me. Will this be on YouTube later? There's a lot of questions about that. Yes, we will have it up on YouTube. So I think we'll be posting it on our social media. So it's Los Angeles County Sanitation Districts. You can go there and watch the video, the recording of this tour. So the next one.
The other thing I want to mention, sorry to go back to the pandemic effect, is we could probably refer them to that link on our webpage that shows we've been doing some research where we're looking at the amount of coronavirus in the wastewater coming into our plants, to kind of see what the baseline is and then see how it's gone up and down or how it varies compared to what's happening with the number of positive tests in the community. So, but also with that said, we've also tested the effluent coming out of all our plant, or a number of our plants, and there is no coronavirus coming out of our plants in the effluent.
Okay, great. So I'm going to give us 5 more minutes to answer some joint plant questions, and then we'll begin our Bixby Marshland, our walk through the Bixby Marshland, and then after that we'll answer some more of these questions. So first, we got 5 minutes. What are some of the weirdest things you found while processing the waste? I love this one too.
Well, the most gruesome is obviously body parts, unfortunately, that victims of crime that have been cut up and put in the sewer. Yeah, there have been like big wads of cash that have come out in the grid chambers. People have called and said, asked our sewer crews, you know, I was washing my hands and my ring fell down, got flushed down the drain or washed down the drain in my sink. Can you check the sewer and see if it's in there? But as you saw from that earlier picture, the size of the sewers, it's virtually impossible for us to find something like that. But yeah, I think the mattress was probably one of the most odd things to wash up in there.
That is very unusual. So the next question, is there a method to trace and identify prescription medication in the sewage, and how would it affect the water that is recycled into drinkable water?
There's methods to measure what's in the sewage, and then what's in our effluent that's being reused, but all of that is taken out in the reverse osmosis, and they're able to monitor what comes out of the reverse osmosis process, and make sure there's no pharmaceuticals in the water that's being used for drinking or being recycled for drinking water.
Great. So our next question is there a map indicating where the entry locations for the tunnel construction will be located? It's for Clearwater project.
The entry location, so it's, if you look at the map here, can you guys, if you can see my cursor there, right where the 110 freeway is and the plant is here, that's right where the tunnel access shaft is just south of our plant on our property.
Okay, next question. In the future, is reverse osmosis to turn wastewater into drinking water part of the investment?
Actually, we can back up real quick to that previous question. That I don't know if I had mentioned it earlier when I was showing you the Clearwater project. We actually have a separate website, clearwater.org, that you can go to. And that will, you can get more information there on the Clearwater project.
Yeah, it's clearwater.lacsd.org.
Okay.
Next question, how does sewer water flow into neighborhoods with lots of hills?
Oh,
Are there
wait,
pumps under the street?
Genesis, if I could interrupt. You started to say another question and then I interrupted you, and then I think you skipped the one you were reading about the RO.
I'm not sure. I think I still have it here, but for now we'll do, how does sewer water flow into neighborhoods with lots of hills? Are there pumps under the street?
There aren't pumps under the street per se, but the systems in the hilly neighborhoods are designed to gravity flow to a low point, and then at that low point is where we'll have a pump station located, and we have about 50 pump stations located in various portions of the county. The other thing to keep in mind too is just because your neighborhood might have a slight slope or whatever. Many of these sewers are 20, 30 feet below ground. So the slope in the sewer may be a lot different than what the ground surface slope is.
Okay, great. And then our last question before we jump into our walk through the Bixby Marshland. What does the $25 mean? Were you talking about per household?
Yeah, that price is per single family home. So that would be something that homeowners will see on their property tax. It'll say like, it'll be one of the line items. It'll say sanitation district, and whatever district you're in, it'll have that number. So if you're like in District 8, it'll say San District number 8, and it'll be, and since you pay your property tax on an annual basis, it'll be that $25 a month times 12. So what is that, $300 a year?
Okay, great. So Steve, if you can please stop sharing your screen, and then we'll move on to our next star of the day, and that's Miss Wendy Wert, our civil engineer with the LA County Sanitation Districts.
Okay, I just want to say thanks. Really appreciate everybody showing up. And
Wait, we're not done with you yet though, Steve, because
I know.
we still have some more questions for you after Wendy's presentation.
Hello, everyone, and welcome. I'm Wendy Wert. I'm a civil engineer with the Los Angeles County Sanitation Districts, and normally our Bixby Marshland is open the first Saturday of every month from 8 to noon, and we also like to open it up by appointment. So one of the things that we are able to do now with the current situation is we are able to energize our mission. And now that many of us are homeschooling, we're providing online educational resources such as educational lessons. And we do that for students in kindergarten through college. And I'm having some issues with my PC. So hopefully you guys can still see me. I'm going to close out of a few things. Thank you so much for your patience. It looks like I'm up and running. Today's webinar is going to provide us with an overview of the Sanitation District's Bixby Marshland, and it's quite a gem. It's located here. And let me see if I can get some of these laser pointers. So you can see we were just at the Joint Water Pollution Control Plant, and the Bixby Marshland is located just northwest of that treatment facility. So let's take a look. As you look out towards the ocean here, you can imagine that many years ago, this was formerly part of a freshwater marshland called the Bixby Slough. And the Bixby Marshland was cut off from its supply when the Wilmington Drain was built. And that was in the mid-1970s. So you can see the drain is located adjacent to the marshland. And the reason that the drain was constructed was to protect all of this area from flooding. So as we start our discussion of a marshland, I just wanted to briefly go over what that is. And what we did was we only had 17 acres. So it was our goal as an agency to put as many ecosystems as possible in this small footprint. And so what you're seeing here is we have 5 distinct zones. We have an open water zone. We have a wetlands area. So a lot of times you'll hear the term marshland and wetlands used interchangeably, but technically the wetland is just this wet area in the marshlands. Then we have upland areas that are known as riparian. We also have our meadowlands areas, and then off in the distance we have some upland areas. So let's take a look. Let's get out there. So the marshland is very important habitat here in California, well, actually throughout the world, but it's home in the US to 43% of our federally listed and endangered and threatened species. So these types of environments provide habitat for birds, for amphibians, for invertebrates, for fish, and a diverse group of plants. So we know that they're essential for many migratory and resident birds, but they also have an environmental impact related to water quality. So they improve water quality, they help prevent flooding, marshlands filter pollutants, they also help us recharge our groundwater aquifers, and they sequester greenhouse gases. So I just went through this discussion of what a marshland is, and now as you look at this, you're probably thinking to yourself, that doesn't look like the marshland we just talked about. Well, this is where we were in 1995. So as the sanitation districts, you saw those incredible facilities over at our joint plant. We go through an intricate planning process in order to provide for the future needs of Los Angeles County. And so as part of that, we saw this opportunity to restore a natural resource. And so what the sanitation districts did in partnership with a number of agencies, but we removed non-native vegetation such as palm trees and eucalyptus that you can see here. We also regraded the site, so we improved water flow across the site. So let's take a look. We received, as I mentioned, valuable community input. We have a joint water pollution control plant citizens advisory group. But in order to really maximize the benefits of this area, we needed some expertise. So we hired a habitat restoration firm, and here you see the design as it was proposed. And so in addition to, another reason that we needed these experts and we also needed community involvement was not only did we need to comply with our environmental impact report and the conditions associated with that, but we also needed to obtain a number of permits. So we needed a permit from our Regional Water Quality Control Board. You heard Steve talk about the more than 2,000 20, I'm off by an order of magnitude, the more than 20,000 parameters that his plant monitors in response to the NPDES permits. But also on our side, we needed to comply with a Regional Water Quality Control Board permit. We needed an Army Corps of Engineers permit, and we also needed to get one from the California Department of Fish and Wildlife Services. So as I mentioned, a lot of thought went into this design, and I particularly like this graphic here, because what you're seeing here is the Bixby Marshland, and we're able to see it before any of the vegetation grew in. So this is right when the plantings were there in 2009, and you can see the different zones. So you'll see our open water areas on either side of the bridges, and we're going to go and take a look with some video footage. We also have these wetland areas, which are adjacent to the open water, riparian areas, which you're seeing throughout and along our pathways. We have a meadowlands, and then also the uplands. So let's go look at all 5 of these areas. So you're going to see when you visit our Bixby Marshland, because we can't wait to get everyone back out there again. But when you get out there, what you're going to see is that even our parking lot has been designed as one of these ecosystems. So our parking lot is representative of Area 3, which is riparian habitat. So let's take a look. So as we continue, oh, I don't want to go that far. I'd like to look at the marshland here. So let's see if I can get my video playing. All right. Well, as you enter the marshland, you're going to see, yeah, my video did not play, so we'll just continue. But what you'll see is that even from our parking lot, we're able to see these endangered and rare species. So this is a yellow-bellied sapsucker, and it was photographed from the parking lot, and it drew a lot of bird watchers to our site. We also have a lot of ongoing maintenance activities, and a part of that helps us keep these 5 zones in place. This was also photographed from our parking lot, and this shows the hummingbirds in Torrey Pines. So let's go ahead and continue, and we're going to look at our riparian pathway. So as we walk towards the education pavilion, you can see our riparian pathway here, and some of the ongoing activities include an annual bird awareness training, so nesting birds. So this is one of the few places in Los Angeles County where the, oh good, this video is going, so this is great. This way you guys will get a chance to see some of this riparian habitat. So this is on our way to the Education Pavilion, and once again you see the Sanitation District's commitment to recycling. Even our trash bins are made from recycled materials. Here you see a Torrey pine, so we saw those hummingbird chicks in the Torrey pine, and the Torrey pines are really interesting because there are only about 3,000 that exist. They're natives of San Diego. They're also in the Channel Islands, and the type of vegetation that you're seeing here is this California coastal sage. So here you see a purple sage, and prior to that we saw some Artemisia, which is also known as cowboy cologne. And here you see a larger graphic image showing a close-up of this purple sage that you will see when you do have an opportunity to get out to our Bixby Marshland. So now we're going to continue on our tour, and we're going to go to our Education Pavilion. And when I started my discussion about where we were in 1995, I talked about taking out the eucalyptus trees, and so we were able to repurpose them into some of our educational pavilions. And so let's go ahead and take a look. Here you see this map and this design, and we're going to go ahead and walk towards, now I'm going to pause this here. Oh, maybe I can go back to the paused version. I hope so. Let me see. So this is fantastic because this placard shows you the level of commitment to recycling that the sanitation districts has. So we're committed to converting waste into resources. And here you see a placard that explains how some of the resource recovery facilities have been incorporated into the design of this marshland. So I pointed out that our garbage bins are made from recycled plastic. So talk about completing the cycle. So let's go ahead and walk towards our open water area and towards our education pavilion. And so here you get a chance to look at it close up. Here you see the amount of vegetation that has grown in. So these eucalyptus trees form habitat and form a place for the desert grape. And then also keen observers will notice that this eucalyptus also forms a habitat for the bark beetle. So if you look close, you'll see patterns on this wood, and it shows the life cycle of the bark beetle. The larval stage eats the eucalyptus. Here you see the desert grape. And then one of the things that is so exciting about inviting visitors into the Bixby Marshland is that it really does engage all of your senses. So here you have this 17-acre marshland, and when you're there, you're going to hear those nesting birds. So we saw the caution tape, and we know that we have a number of nesting birds. In fact, back in our annual nesting bird survey in December, we observed, well, actually the Audubon Society helped us to do so, but in 2.5 hours, more than 28 species of nesting birds were observed at the Bixby Marshland. So, and in addition to hearing the birds, you're going to smell that California coastal sage, and then some of our observers will even have an opportunity to taste that desert grape, as you see this person doing here. So as we continue on our journey through the Bixby Marshland, we're now going to walk towards the overlook and also towards the round pavilion. And as we go on this journey, you're going to see area 1 of our marshland that we talked about in the beginning. That's the open water, and also area 2 of the marshland, which is our wetlands. And this is where we get a chance to see all of those birds. So I mentioned 28 species, more than 78 that have been identified at the site. And we're going to get a chance to see some of those in action as we enter this zone. So as we walk towards the marshland area, you're going to see the open water zone. And in the open water area, the Bixby Marshland is a stormwater marshland. And so types of fish that we have in the marshland are typically mosquito fish, which we use for vector control. You're also going to notice some of these marshland rushes or tules, and these tules are uniquely adapted. So their roots can sit in up to 2 feet of water, and then what they do is they take in the oxygen through the stem of the tule. So uniquely adapted rushes, and they provide habitat. So I'm going to back off and let you have a look at this beautiful overlook. It does show the riparian area towards the center of your screen there. And then you also see the open water as well as the wetland area of our marsh. And that gives you an idea of this treasure that we really do have in our community. I mentioned that we have our educational programming in concert with a number of agencies and local organizations. And so here what you see is you see that a nature photographer out at our marshland taking pictures. And then here you see some more of the open water, the wetland zones, and then also the riparian habitat. So I mentioned the tules, and they're really interesting because they form the nesting habitat for the red-winged blackbird. So here you see an image of that bird that does nest in the tules. And then, as I mentioned, when you get to these open water areas, you see magnificent birds such as the blue heron. You'll also see the American coot. And then here, this is just wonderful, and we're gonna get it, yay. So I mentioned, and Steve also talked to you a little bit about the maintenance activities that we have ongoing as part of our operations. And annually we have to clear out about 1/3 of the tules. And we do that in order to maintain these open water areas so that these ducklings can learn to swim. Mallard ducks are a great example of the type of creatures that need these various ecosystems that we do have in our marshland. So they use the open water, as you're seeing right now, in order to swim. They use the wetland areas or the shallow areas to gather their food. And then they also migrate up into the riparian areas in order to nest and lay their eggs. So a habitat is obviously, it's where we live, and it provides all of the things that these creatures need in order to complete their life cycle. And here you see another creature, an amphibian, that is typical of this riparian area because they need the water in order to lay their tadpoles. Then they migrate up onto the land for their life cycle. An interesting fact about the Pacific tree frog is they have a ferocious appetite, and they can eat about their same size in insects. So we'll continue on. Okay, now we're going to continue our journey, and on this portion we'll have a chance to see the Wilmington Drain and the area. So we're going to be traveling from our pavilion, and then we're going to walk along a path that'll take us over to where we can look out towards the source of water for this wetland area. So I mentioned that it was done in partnership with Los Angeles County Flood Control District, and we have a pump station that pulls stormwater into our marshland. So let's take a look. So as we walk, we're going to see more of that riparian habitat. So here you see some of our sycamore trees. Here you see some elderberry, and elderberry, I guess, gained some fame and some notoriety because of the straight wood is apparently very good for wands during the Harry Potter series. And here you see some younger sycamores. We did have some Farsonium dieback, and it's a fungus that, as a result of the drought, infected some of our sycamores, so we had to remove those. But it's exciting to see that some of the younger species are coming in. Wetlands are sometimes called the kidneys of the landscape, and that's because as the water comes onto them, it slows down. And as we go to an overview on my next slide, I'll show you how the water, once it's pulled from the drain, flows gently across the land, and then it's filtered, and that helps to clean that stormwater before it joins the environment. So here you see the Wilmington Drain, and this is the source water for the Bixby Marshland. So we have our pump station that the Sanitation Districts maintains, and then we also maintain the freshwater marshland. And for Bixby, it's not associated with its source water. So this graphic here does a really nice job. I'll spend just a little time here showing you how the water flows across this 17-acre site. So here you see where we were standing. We were standing looking out at that pump station from the Wilmington drain. So we pull water from the Wilmington drain, and then it goes through those different habitat zones, those 5 areas that we talked about, provides habitat, filters out some of the pollutants such as some of the sediments, and then is returned to the environment. So you can see how the water flows through the marshland. And now we're going to spend a little bit of time walking along a vegetated riparian pathway that's part of Area 4. And the plants in the riparian zone are really well suited to this area because what they can do is they can handle a lot of water in the winter time when, particularly this year, we had quite a bit of water on the roots. And then in the summertime, they're also resilient enough, such as now when we're into triple digits, to handle the heat and the dryness that we experience here in Southern California. So some of the types of vegetation that you'll see out there are, again, the sycamore tree that we talked about. You'll also see cottonwoods, and here you see another of those Tory pines. And here you see a cottonwood. And some of the interesting things, and that's the sycamore right there. Some interesting facts about the sycamore trees is they have the largest leaves of any tree in North America. The chips from the bark can be boiled for a coffee-like beverage. And another name for sycamore is buttonwood because that hardwood is excellent for both butcher blocks, and historically they were used for buttons. One last fact before we leave the sycamore is that it provides a larval home for the western tiger swallowtail butterfly. So it's a magnificent creature, and it does start its journey in sycamore trees. So let's continue, and actually we're going to complete our tour with a visit to areas 4 and area 5 of our marshland. And so this would be the meadowlands as well as the uplands. So let's take a look. So some of the types of creatures that we see in these meadowland areas are some of the mammals. And here you see some that we've seen out there. The raccoon, the skunk, and also the coyote are in the meadowlands and also in our uplands areas. So let's go ahead and take a look. As you can see, our California coastal sage vegetation, and here you see Artemisia, and I wanted to tell you a little bit about it on our previous walk. Artemisia is also known as cowboy cologne, and back in the pioneer days, the cowboys would be out on the trail for a long time, and then they would come into town, and they were encouraged to go and roll around in this sage because it is so fragrant. And so here you see the meadowlands, and then across the water, you'll also see our uplands area. And so in the meadowlands, we have a lot of grasses, as you can see, and that's area 4. And of course, what we find in those grasses are the desert cottontail. So some interesting, they like to hide in the grasses, and that would be from some of the predators such as the hawks, the owls, and the coyotes that we've seen on the previous slide. Also, they eat the grass, and then these creatures who have only a 2-year lifespan, they are very busy. They raise about 20 to 30 young in their lifetime. And then as we look out across to those uplands areas, you're going to see a magnificent bird. This is the American kestrel, and that is the smallest hawk in North America. And it eats bats, rodents, insects, frogs, small reptiles, and birds, and then they nest in the holes of those trees that are located in our uplands. So hopefully my discussion has sparked your interest in the Bixby Marshland. We host nature walks for children normally. I know we're in this situation right now, but under usual circumstances, we have native gardening workshops, and we do this programming in partnership with other organizations such as our bird walks, which will be led by the Audubon Society. So what I wanted to do was just encourage you to continue to be engaged with the sanitation districts through these virtual forums. And it's really, we are pleased to have been able to restore this environment so that we can provide a home to plants, to animals, and then also to improve water resources in our region. So please do visit us again, and also spread the word to your friends and your family. Soon, cross fingers, right? We're going to be open again the first Saturday of every month. But until we're open, we have started as early as May. We started broadcasting information and featuring some of our docents from our Bixby Marshland. So that happens even now, the first Saturday of every month. But until you can see us in person, we're going to send staff into your homes and into your classrooms. So thank you again for joining me on this virtual tour. And as I open it up for questions, I'm going to end with, believe it or not, this is my 82-year-old mother, and the Bixby Marshland still has opportunities for learning. She's a retired school teacher, but I think throughout your journey here in Los Angeles County. So with that, I will open it up for questions, Genesis.
Great, thank you, Wendy. First question, someone who has their hand raised, Linda, would you like to ask your question? I unmuted you. I think Linda, oh, she lowered it. Okay, so we'll move on to our next question. Can you please define riparian?
Oh, right. I can do that. So the riparian zones are the places in between the open water. So you have this wetland area where the water sits. So that would be where the rushes are. And then you have more of the uplands or the meadowlands, which are at a higher elevation. So I probably should show you on our overview. I can do that if I share my screen again. But these are the zones in between the wetland area and also the meadowland area would be those riparian zones. And that's where the vegetation can handle the wetness in the wintertime here in California, but then can also tolerate the dryness in the summer.
Okay, perfect. And so do we still have Steve on the line? Because Steve, we have some questions for you.
Yes,
there you are.
I'm here.
Yay.
I'm hiding in the background.
Okay, great. So we have a few more questions for Steve. This is, which are the power stations that receive power from your facility?
We export to the grid here. So what Edison does once it gets into their transmission lines, where they route it, that's up to them.
Okay, great. And then are metabolites and estrogen compounds removed?
I don't know if, is that related to the joint plant? Or
Yeah, from the joint.
Okay, yeah.
That was from the joint.
Some of that stuff is taken out, but as I mentioned, our process is we take out the suspended solids and we take out the biological, the process to take out the dissolved organic material. Some of that is, those compounds obviously go out with the solids, but some of those things will pass through in very trace amounts. I know in the past, when we could only measure things analytically to parts per billion, you didn't see things, but now that they can do much more detailed analysis down to parts per trillion, you do see trace amounts. And then, as I think I answered earlier, when it does go to the reverse osmosis through the advanced water treatment, that stuff is taken out before it would go in the drinking water, so it would not end up in the drinking water.
Okay, great. And then our next question is, do you separate high COD and low COD?
No, we don't. The industrial dischargers, they, as I mentioned, we have a pre-treatment program, so our industrial waste department oversees the permits for industries and commercial entities to discharge to us, and they have limits. And depending on what those limits are, it could be high or low. And the higher it is, the more we have to treat it, then the more they have to pay, and vice versa. So, but yeah, it all goes into those 1,400 miles of sewers. It gets mixed in, and it's all mixed together when it comes to us.
Okay, great. And you were talking about the Regional Recycled Water Project. So Mr. Jason Bohr asks, will you need to tap into new power sources to run the Regional Recycled Water Plant, or do you generate enough power to supply on site? Will local refineries be able to supply you with power from the cogens?
From their cogen?
Yeah, cogens.
That's a good question. And those, the answers to that are unknown at this time. It's going to depend on the process that's selected ultimately, and it may be a factor of how much food waste we're able to get into if we've got the power. But most likely, if I had to guess right now, it would be a separate power connection to that facility. And they refineries, we wouldn't get anything directly from them, but if they're exporting from their cogen to the grid, then we would, if we are buying the power from Edison, it could be power from them. We wouldn't know that specifically though.
Okay, next question. Is reclaiming wastewater for drinking water cheaper than desalination?
Yes, and the reason is because when you do desalination of ocean water, it's a much higher salt content than the amount of salt that's in our water.
The next question, it could be for either both of you, Wendy or Steve. So storm drain water leaves the marshland after being naturally filtered by the marsh and returned to the storm drains where it is picked up by the neighboring sewage plant? If so, is this water tested?
Well, let me back up a step here, because I probably should have mentioned this at the beginning, but when we talk about the sewer collection system and the storm drain collection system, in many cities, they're combined together in one set of pipes. Here in Los Angeles, we have two sets of pipes under the roads. We've got one set as a sewer collection, and that's the 1,400 miles that come to this plant. When Wendy was talking about the storm drains, that's completely separate system from us, and those flow directly out to the ocean. And you'll see in your neighborhood, you'll see a lot of signs on the catch basins saying no dumping, drains directly to ocean. It might have a little blue fish next to it. And that's for public outreach to let people know that if anything goes down the storm drain, you're polluting the ocean. It's going directly out there. And that is the biggest impact on ocean water quality. And you've seen it, the pictures on the news and the newspapers after a rainstorm, all the trash and debris that gets washed out there. And that's the reason too that a lot of cities have these street sweeping programs, is to get all the leaves and other trash off the streets so that it doesn't end up in the storm drain and ultimately out in the ocean. So, but as far as with the marshland itself, that water in the storm drain, it actually flows down to Machado Lake and then out to the ocean. So there is no treatment plant on the storm drain system anywhere. We do have, and we've started doing this more, is because we have excess capacity in our plant right now, we've done some dry weather diversions throughout the county where during the dry weather, we're able to divert water from the storm drain over into the sewer and get it to this plant. And there's actually in Carson here on the corner of Sepulveda and Figueroa Street, there's a project where the park's been all torn up there, and they're putting in a pump station to actually divert stormwater, at least the first flush, into our sewer system. So we can treat that and keep the ocean a little bit cleaner. Did you have anything else to add, Wendy, maybe?
Just that the marshland does, and I think I touched on it briefly, that they're known as kind of the kidneys of the environment. And so that stormwater that comes in and then is routed through the marshland is filtered. Most of it goes back into our aquifers, but we could put it back into the Wilmington drain before it goes out, and it would be a lot cleaner after having been in the marshland.
Okay, so Wendy, this is a question for you. Are animal habitats controlled for which species are entered in from outside or just left untouched to interact naturally?
So yes and yes. What we've done is we've designed the wetland in those 5 different zones in order to accommodate native species and vegetation. Now, with respect to the vegetation, and I think I touched on it slightly, but we have maintenance activities out there all the time to remove those invasive plants. So to answer your question with respect to plants, yes. With respect to migratory birds, we're on the Pacific Flyway, so we encourage all birds to migrate to the wetland. So regarding the types of plants, we're very specific about the California coastal sage, which would have been naturally occurring in this area before all of us came here.
And then Wendy, regarding core curriculum, do you know what grade would benefit most from a tour of the Bixby Marshland?
All of you. we have water quality studies. We have groups that are doctoral candidates that are out there, and we've hosted that. We've had MIT folks come out, which is just fantastic. And then we have the little ones out there that go and they look at the insects. So we do insect walks, and they're fantastic. So all of you, and you saw my 82-year-old mother who's a retired school teacher who's still learning from the Bixby Marshland. So we will gear it to whatever group that that you're interested in involving, but please do reach out to us.
Okay, perfect. So then our next question is for Steve. So is the treated wastewater going to the ocean, or is it becoming our drinking water?
Right now, for the upstream water reclamation plants, over 100 million gallons per day. It actually, some of it goes to drinking water through groundwater recharge to the aquifer, and a lot of it is reused for irrigation up in the Lancaster Palmdale area. They actually use it for irrigation of farms up there. But down here at our plant, the Joint Water Pollution Control Plant, other than the 25 million gallons per day that we reuse inside the plant for processes, the rest of it all goes out to the ocean. And that was kind of the driver for the regional recycled water project with MWD, is to be able to take that 150 million gallons per day of our water and ultimately reuse it for drinking water.
All right, Steve, we're almost done grilling you. So our next question is, where is it? Oh, so can you talk, and this is a good PSA, so I'm happy to bring it up again. Do you think there should be labeling regulations about calling wipes flushable to prevent them from actually getting flushed? This is my favorite topic.
Yeah, it's a great question, because yeah, when the wipes industry has been labeling it flushable for years, which basically says, yeah, you can flush it and it won't plug up your line going out to the sewer. But that's all it really means, is that it's able to get out of your house and into the sewer. But yeah, our industry has been working with the wipes industry for a number of years now. It's actually looking pretty promising as far as relabeling from the latest proposed regulations that have been floating around. But yeah, there's been a big pushback from the wipes industry, because they know by not having that flushable on there that people might not use them as much. And obviously it's all about money. So they're not going to make as much money if people don't use wipes as much. So but hopefully there's an end in sight on that. And you know, I showed you the one picture of the bar screen, how bad it was, but you know, they've pulled what they call fatbergs out of the sewers, where these wipes mix with the oil and grease, and they just create these huge blobs in the sewer that plug sewers. And then it's an impact on public health, because then it plugs up the sewer, and then you have raw sewage coming out of the manhole and flooding streets. And I think London was notorious. They've got some of the best pictures of the fatbergs they've pulled out of their sewers.
Okay, so this next question is, actually, you can probably answer too. Sometimes I've seen raccoons in the storm drains. So do a lot of animals get washed out to the ocean?
I couldn't answer that. I don't know.
I
I
know.
haven't been out of the ocean looking for animals.
There are a
They
lot.
swim.
There are a lot that end up and kind of migrate to the Bixby Marshland. So we've been excited to see coyotes and raccoons out there. But yeah, I don't know. I know that if you look at your storm drains, that they do have, I know Steve went over to some of the bar screens that are part of the headworks. So in some cases, those are in place, which may help to protect some of those creatures. But you're right. I guess if they live there and then there's a flood, they may indeed get washed out. I don't know of any numbers associated with that.
And then speaking of creatures, is there a main predator at the Bixby Marshland, Wendy?
So we have hawks, which of course, unfortunately or fortunately, you see it all happening out there. I think in our last bird survey, we did see a hawk eating one of our field mice. So they, rather than just showing the birds, they had to show the bird interacting with the animal life out there. So to answer your question, yes, we have coyotes out there that are predators, and we do have hawks that are also predatory.
Okay, next question is, it's kind of for me. Where will these videos get posted? So we will have a link up at in our social media on Facebook, Twitter, Instagram. We'll have the link for YouTube. We'll post it up. I'll see if we can get a link in our bio. So you should see it early next week on Monday. And then the next questions, I think that is it, you guys. Thank you for putting this presentation together, or all the comments that I'm getting now. Great presentation.
Well,
Well
thanks.
done.
We really appreciate everybody showing up and listening.
Yeah, thank you. We really appreciate
your Saturday with the districts. We enjoy it.
Thank you for coming, and just remember, your wipes clog pipes. So be careful on what you flush down the drains. Hopefully now you have a better picture as to what happens once it leaves your toilet. So with that, thank you everyone, and have a good Saturday. Have a good weekend.